This and the coming right hand thumb rule are kind of identical. So I am going to explain that cumulatively. Why I'm saying cumulatively? Because it's the same explanation. But I will give it twice. Don't worry. Is the left hand rule okay? Left hand was A cross B. A was the middle finger. B was the forefinger. It matters. So when you write A cross B, the first one gets the middle, second one gets the fore, and the thumb will give you A cross B. Perfect. Screw rule. Let me illustrate the screw rule with the help of an example. A screw. This is a bottle cap or tap of a wash basin or bathroom, a tap. You want to understand how this screw was designed. Where does it open? Clockwise or anti-clockwise? Clockwise. Now, to understand the direction part, the screw part, keep your thumb in the vertical direction, like this. Tell me, in order to open this cap, should this cap come up or go down? Sir, come up, obviously. All right. How will you align your right hand, the fingers, so that thumb is in the direction of the cap? This way. Tell me, how are the fingers going? This way. See? This is the way cap comes up. Got it? In order to close this cap, where should my thumb point? Where should the cap go? Sir, down. All right. In order to go down, look how automatically my fingers gets aligned into the clockwise direction as I look from above. There you go. That means screw rule. Thank you, Waddle. So that the screw rule is actually a convention in which the screw will go as I rotate. But sir, what are we rotating here? Mentally rotate your hand from one vector to the other, and again, the order is important. So if somebody has written A cross B, try to rotate from A to B. If I try to rotate from A to B, the screw, the direction of the screw will give you A cross B. Is that okay? Everyone, I'll repeat. When you rotate, if a screw rotates from A vector to B vector, sir, who is A, who is B? Your call. If you are saying A cross B, then rotate from first vector A to second vector B. If you want B cross A, rotate from the first vector B to second vector A. The position of cross product matters. In A cross B, you will rotate from A to B, then the screw will go in the direction of A cross B, and believe me, this is the convention they follow across the world. Alright? Think, as I said, cumulatively, because the second one is also based on the same thing, and it is my personal favorite because it's the simplest of all. Right hand thumb rule. This is one unit. All your four fingers together is one arrow. One arrow. Align this arrow, not this way, this way. First of all. So the right hand thumb rule works not in this position, but in this position. Slicing position. Point number one. A cross B. Align this arrow along the first vector A. Align, sir. Curl your right hand, again as a unit. Curl this along the B. A, B. The thumb will point in the direction of A cross B. Finished. Did you see when I applied this law, I kept the stylus down? Tip. When we are writing, most of us are right-handers. Okay. So the basic thought sometimes comes, let me use my spare hand. Please don't do that. That's a left-hand rule. So if you want to apply the right-hand rule, keep the pen down and then apply. Again, A cross B. Align your hand in the slicing way, transverse way along the first vector, and the four fingers are one unit. Don't keep them like this. Keep them together. Align along A, curl along B. That's your A cross B. Align along B, cross A. That's your this vector. Hey, A cross B up, B cross A down. That means not only A cross B and B cross A are different. I also know that one is negative of the other. Bingo. So three different laws. I am biased towards the right hand thumb rule. Curl your fingers of right hand from the first vector to the second vector, and the thumb will give you the A cross B. Understood? Perfect. Geometrical interpretation. Why? Who inspired you to think about A cross B? Okay. Geometrically, the cross product of two vectors is the area of the parallelogram formed by taking them along two adjacent sides. So A and B are two vectors, angle theta is between them. Complete the parallelogram. Find out the area. Okay, find out the area. What is area equal to? Base into height. Alright. Till now you're with me? No, you're not with me. Don't fake it. You know area of parallelogram is base into height, but you don't know how this thing is leading to cross product. So say no. Sin theta DE upon AD, D equal to AD sin theta equal to B sin theta, base height, blah, blah, blah. No. This cannot be the inspiration. Seems like suddenly I was teaching you cross product and I've gone tangential to teach you area of a parallelogram. How is this the inspiration behind cross product which contains A, B sin theta? Fair. There is a sin theta here. What about n cap? What about n cap then? Last question please. Is area a vector quantity? Let me give you some beautiful insight. Length, area, volume. Length AB, it matters whether you are going from A to B or B to A. Length is a vector quantity. Is area a vector quantity? How about I give you a sheet, a rectangular sheet for dimension 10 centimeter by 10 centimeter, square sheet, 10 centimeter by 8 centimeter, rectangle I said. And I give you exactly 80 centimeters square worth of scotch tape. And I ask you, can you cover the entire area with that tape? Now, you have exactly 80 centimeters square worth of tape and the dimension of the plate is 10 cross 8. How much is the area? 80. How much plate area is required to be completely covered? Technically two sides, 80 and 81, 60. But you have how much tape? 80 centimeters square. What's your obvious question? Which side do I tape? Isn't it? See? Which side? So let's say the answer is, okay, how about my palm? My palm is a plate. How about the answer is, okay, tape or paint this side. Occupy this side. But this side is not scientific. This side is not direction. Alright? Upper side. Upper is not a direction. Okay? The one which points upwards. There you go. The one which points upwards. Okay? How can this palm point upwards? Is it point upwards now? If I draw a pointer, a vector, which is pointing in the direction this palm is facing, then this can be used to give the uniqueness of the side. Isn't it? This is palm, this is back of my hand. If I ask you which side is palm? Upper side. No. Upper is not direction. Which side? The part of your hand facing or pointing the roof is your palm. There you go. Facing or pointing the roof. Now, add a vector which literally points towards roof. Do you see the origin of n cap first of all? Perfect. And do you see how sin theta comes into picture? Two lessons learned here. Area is a vector quantity first of all, and the inspiration behind cross product is actually area of a parallelogram. Let's revisit this thing again. A and B are two adjacent sides of a parallelogram. Angle is theta between them. Base into height, if I drop a normal from D point on the AB vector, E is the foot of the perpendicular, and by simple trigonometry, B sin theta is the height. So base is A, B sin theta. Area of the parallelogram is AB sin theta, which is a nice, tailor-made, customized expression for your cross product. Right? I will revisit this, don't worry. Find the magnitude and direction of A cross B and B cross A, where A cross B lies in XY plane. First of all, even before I start the question, even before I go into the properties, my personal experience, my curious nature tells me that once I flip the order of A and B in the cross product, the answer is going to be negative of each other. Why? Mod A is positive, mod B is positive, sin theta, whatever the value is, stays like that. Who will govern the sign? N cap. So I will have two similar answers differentiated only with what? Sign. There we go. So mod A, mod B, 5 times 4. What's the angle between them? 30 degree. Sin 30 is half. So I have a 10. Now, Once I know this, I know that magnitude is 10, but what's the direction? XY plane. Alright. So XY plane, you want A cross B. First of all, what is the direction which is perpendicular to both X and Y? Z axis. Right? But which one is plus Z and which one is minus Z? Right hand thumb rule. Put the pen down, free your right hand, align your right hand along it. Do this as I'm saying. Don't look at me. Look at this, look at the mentally, just involve yourself in the vectors and hear me. Align your right hand fingers all together along A vector and curl it towards B. Curl it towards B. The thumb goes down, minus K cap. Align the fingers of your right hand along B vector and curl it towards A. The thumb will give you plus K cap. A cross B is minus 10 K cap and B cross A is plus 10 K cap. Understood? Good. If not, don't worry. We are on it. Vector product of orthogonal unit vectors. Extremely important. Arch your back. When I taught you dot product, I said what is I dot I? Mod I cos 0, 1. What is I dot j? Mod j cos 90, 0. Any unit vector dotted with itself gives you 1. Any unit vector dotted with another perpendicular unit vector is 0 because cos 90 is 0. Let's do the same thing for cross product. First of all, obviously, what is I cross I? What happens when a unit vector gets crossed with itself? Mod I, what's the angle? 0. Sin 0, 0. So first of all, this is done. Any unit vector crossed with itself gives you 0, right? Perfect. Now what happens when the other counterpart, the perpendicular counterpart is crossed? Now guys, pay attention. I cross J is K. That makes sense, sir. Because I is along x-axis, J is along y-axis. So when I cross them, I want a vector which is perpendicular to both of them. Z is fine. J cross I is minus K. But sir, how did you decide that? How did you decide that your I and J will give you K and J and I will give you minus K? You should have asked this question to me in the previous example, but you didn't. You didn't. Now I'll tell you what am I talking about in complete sense. X, Y and Z axis, X, Y and Z axis, plural, cannot be assumed randomly. There is a logic to it. When you draw X, Y and Z axis, there is a logic. You can choose only 2 out of 3. The third one is chosen for you. Now pay attention. I cross J will give you K. There is a cyclic order in making. First comes I, then comes J, then comes K, and then comes I again. The cyclic order is I, J, K, or rather just one cycle, I, J, K, I. And if I go in cyclic order, if I do my cross product in cyclic order, I get the third one. I cross J, K. Is I, J, K a cycle? Yes, sir. J cross K, I. Is that a cycle? Yes, sir. K cross I is J. Am I still in cyclic order? Yes, sir. And what happens if I reverse the cyclic order? Well, duh. If you reverse, you get a minus sign. Right? That's the logic and explanation of cross product of orthogonal vectors. But thing is not done here. You have to be careful. Let me give you an example. What if you have to solve minus I cross K? Minus I cross K. Tip number 1. Keep the minus as it is first of all. Don't touch the minus. Okay, sir. Then tip number 2. I cross K. Since they both are 2 unit vectors which are mutually perpendicular, immediately write the third guy as the answer. Who's the third guy? I and K are involved. Third guy is J. Tip number 3. What was tip number 1? Leave the minus as it is. Tip number 2. Write the third guy. Tip number 3. Check the order. I, J, K, and then comes I. So the correct order is K cross I. This is I cross K. So put an extra minus sign. Minus I cross K is minus of minus J, which is plus J. One more time. Okay. Minus K cross minus J. Tip number 1, take care of the signs first. What is minus times minus? Plus, plus. Tip number 1, take care of the signs. Tip number 2, K and J, write the third guy. Tip number 3, check the order. I, J and then K. So J cross K is a cyclic order. K cross J is opposite. Minus sign. And minus K cross minus J would be minus I. Is this clear? Have I made myself the cyclic order clear? IJK, IJK. We will use this in order to define the cross product in composed form or unit vector form. A is AXI plus AYJ plus AZK. B is BXI plus BYJ plus BZK. What is A dot B? The peaceful formula. AXBX plus AYBY plus AZBZ. What is A cross B now? That's the question. Okay? Perfect. What's the first term? Before I even start. First term is open them up like polynomials. The way we did it. So how many terms? 9 terms. Each of the first gets crossed thrice. Which in each term of the second bracket. There you go. So I wrote the 9 terms first of all. Yes, a pleasant surprise. Not as pleasant as a dot product, but still a pleasant surprise. 3 things will become 0. Why is that? I cross I 0, J cross J 0 and K cross K 0. The remaining are 6 terms for you. And how will you write those 6 terms individually? You will write them using what I just taught you, the cyclic order of orthogonal unit vector cross multiplication. How I, J, K run in the cycle. Can I give you an example? Okay. K cross J. Tip number 1, check the sign. No sign, sir. Tip number 2, draw the bracket and write the third guy. K cross J. The third guy is I, sir. Right? I. And K cross J. The order is IJK. K cross J is opposite. So minus I, sir. So AZBY will have a minus I cap. See? AZBY will have a minus I cap. This way you write all the 6 signs and then you club them I with I, J with J and K with K, and you get your result of A cross B, which is not that pretty looking. Is it? No. Sir, should I remember this result? Absolutely not. No. Why? Because if you remember this result, you are bound to make a mistake one way or the other. And first of all, your data space is occupied with this result. Second, you remember it wrong. No, I don't recommend. I strongly recommend don't remember this result. But sir, then there must be a shortcut. There is. So let me teach you something which you will revisit in mathematics anyways in much detail. But as I said right now, mathematical tools, I require it. I'm teaching you mathematical tools. And what I'm about to teach you is a mathematical tool. So I will teach you that. Alright? Before that, let me first take the build up. Okay. Let me first tell you how difficult it is that this method is employed. Then you will appreciate the smaller cut, the shortcut better. A cross B. A, 2i, 5j, 3k with the minus sign. B, 3i, 4j, 9k. So, method says first you write the 9 terms. I wrote the 9 terms. Clearly, I cross I will be 0. Clearly, J cross J will be 0, my bad. And K cross K will be 0. 3 terms are 0. Remaining 6 terms, what do? You follow the cycle. Now you know how to do that, okay? So I'm giving you the result. Trust me on this one, I followed the same thing, I, J, K. Once I do that, I get the answer 33I, 27J, 23K. Looks like a little cumbersome, right? How about I teach you the trick, determinant method. 2 things I want you to understand before I start teaching you this. Point number 1, this will come in great detail in mathematics, 4th or 5th chapter from now. Okay? And second, pay attention. It's a trick very useful in cross product. A determinant is nothing but a matrix or an array of a 3 cross 3 arrangement. Sir, only 3 cross 3? No, it can be 2 cross 2, 4 cross 4 also. But wait, we are right now concerned with 3 cross 3. Okay? Okay? Sir, so you will write those 3 in a row. 3 by 3, 9 terms. Yes. But sir, what does it mean mathematically? A cross B is given by opening the determinant. So what I'm about to do, again I'll go back. A cross B, look at this. A cross B is AX I cap plus AY J cap plus AZ K cap cross BX I cap plus BY J cap plus BZ K cap equal to, note the equal to guys. That means first of all you have to write these two vectors in a format like what I'm showing. So what is the format? Draw two parallel lines. The top row will always be IJK. The top row will always be IJK. The middle row will always be the components of the first vector because in cross product order matters. The third row will be the second vector and its components. Order matters. Okay. So sir, what does this mathematically mean to me? Now watch what I'm doing. A cross B. What was the first term in the formula? It was AY BZ minus BY AZ. The result. Okay. It looks like I have multiplied AY and BZ. I put a minus sign in between. Then I put BY and AZ. Okay. How do I remember which one did I multiply? Okay. When you have the I cap term, when you have the I cap term, notice you did not take anything of the I cap row, column, X and Y. And there was no J and K. I repeat, when you have the I here, you have nothing from the first column which belongs to X and you have only I. So you have nothing which belongs to J and K. It looks like as if when you chose your I term, you took nothing from the row which are involving I and the column which is involving I. Repeat, when you are opening the I term, you took nothing from the row involving I, you took nothing from the column involving I. What's left is these four. How do you multiply them? AY BZ first minus AZ BY. This you will learn later is called the cofactor or minor of the determinant. There is a difference between the two, but the nomenclature is that. Alright sir, next what? Watch. J, let go of the column containing J, okay. Let go of the row containing J. Gone and gone. And then how do you multiply? Always left to right. AX BZ minus BX AZ. But sir, there is a minus sign here. I know. I'll come to it. Hold on. Plus K cap. Leave the row containing I, J and K and leave the column containing K. Again, left to right. What did you learn? Step 1. I, J, K, when I open, there will be first of all 3 cumulative terms. Agreed. Tip 2, step 2. When I am opening it along any member I, J or K, I should banish the row and the column containing that term. I'll go back again one more time. Look at the I term. When I solve it using I term, I gone remaining 4 AY BZ minus AZ BY. I always multiply starting from the left corner. Then comes the second term. Forget the minus sign right now. Again, AX BZ minus AZ BX. I always multiply starting from the left hand corner term. Third term. K cap. Again, those things are left. Remaining 4, I always multiply starting with the left hand corner term. Got it? Now, as far as the minus sign in the middle is concerned, remember this thing. Plus, minus, plus, minus, plus, plus, minus, minus, plus. How do I remember this, sir? They are always protected and 4 corners by the plus thing. That means whenever you open a determinant, either along the row or the column, I taught you to open along the row? Yes. Remember that. When you open it, then as if like when you open it with the J cap, a minus sign is carrying forward because this is the sign which is mapped on the determinant. How do you remember this? It's always alternate no matter what direction you go, and these are cornered by 4 pluses. So this guy was I cap, this guy was J cap minus sign, and this guy was K cap. Guess what? Had I opened it using the columns, I would have still gotten a minus sign in the middle. So either way it makes sense. Understood? How about I apply this for you and teach you how to cement it. Like I want to solidify this in your head. 2i, 5j, 3k, 3i, 4j, 9k. Now is the turn for determinant method. Alright. Step 1. Create the determinant. There you go. First line, ijk. Second row, the first vector, 2, minus 5 and 3. Third line, the second vector, 3, 4 and minus 9. Shall we open it? Understood. Okay? Understood. Understand, please. First term, I cap. First term, I cap. Is it a plus I cap or minus I cap? Plus I cap. What comes in the bracket? Multiply the cross terms minus the cross terms. But sir, which order? Always start from the left hand corner. Minus 5 times minus 9 is plus 45. Plus 45. Minus 4 times 3, 12. Then comes j cap. Is the middle term? Yes. Look at the minus sign here. Minus j. How do I multiply, sir? Always start from left hand corner. 2 times minus 9, minus 18. Minus 3 times 3, 9. Plus k cap. 2 times 4, 8. Minus 8. Minus 15. Which makes it plus 15. What do you have? A cross B, 33 I cap plus 27 j cap plus 23 k cap. No need to remember the cross product in resolved form. You have determinant form in front of you. Is this clear? Have you understood how to open a determinant? Good. Shall we go ahead? Perfect. Alright, time for properties of cross product. While I was explaining the cross product to you, a lot of things have been explained already, which will come again as properties. But still, for completeness sake, let's scan through. Cross product of two vectors is always orthogonal to the plane. This is the very definition. N cap vector is a unit vector which is perpendicular to both A and B. What's the better way of saying this? N cap or the cross product vector is perpendicular to the plane containing A and B. That means cross product can give you a vector which is perpendicular to both A and B at the same time. Not commutative. Finally, we have been saying this all along. It's not commutative. In fact, it's actually having a minus sign. A cross B is not equal to B cross A. In fact, A cross B is minus B cross A. But the magnitude is mod A mod B sine theta, which remains same. It is distributive just like dot product. A cross B plus C, I'm allowed to open the bracket. A cross B plus C is A cross B plus A cross C. I can open the bracket and divide the entire thing into two vectors. Vector product of two vectors will be maximum when the vectors are orthogonal. Of course, sine theta is equal to 1 when the angle is 90 degrees. Absolutely obvious choice. And its minimum magnitude when they are parallel or anti-parallel. I am not taking sine theta as minus 1 out here because it's n cap. But sine theta is minus 1 anyways in a obtuse range. So from 0 to 180, why is that? Because the moment somebody takes angle between two vectors into consideration, two things. First, tail to tail. Second, smaller value. So the angle between two vectors is actually between 0 to 180 on a plane, right? So what's the value at 0? 0, sine 0. What's the value at 180? Again 0 and 90 plus 1. So minimum value of cross product will be 0. Area of a parallelogram. History repeats itself. This is how it started. Let's address this again. I have already given you the inspiration part. How? Two ways. First and more important. Area is a vector quantity. How did this concept came about and introduced n cap? And second, mod A mod B sine theta. The story is all there. Let's stitch it together. Look at the diagram. Base A, height h, which is equal to b sine theta. So area of the parallelogram is AB sine theta, which clearly is the magnitude of A cross B. So what is the formula of area of a parallelogram? It is A cross B, sir. With mod sign, no. It is A cross B. Because area is a vector quantity. And what's the magnitude? Magnitude is mod A mod B sine theta. Hey, tell me, how do you draw your n cap in this direction now? I promised you about the axis, I'll deliver. If somebody draws x-axis like this and y-axis like this. If somebody draws x-axis and y-axis the way I have drawn on the screen, should I now choose z-axis? No. Out of the 3 axes, you can choose only 2. The third choice is made for you using cross product. 2 things you will learn now. First thing is that choice. Curl your fingers from I to J, X to Y, and the thumb should give you Z. That means Z will be coming out of the screen towards you. How do I draw that on paper? With a beautiful sign convention of dot. This is Z. Dot towards, cross, away. What is dot and cross? How did they come about? Arrow. When you launch an arrow and it's going away from you, what do you see? A cross going away. That's the reason why the last bogie of a train has a cross. So that when anybody sees that cross, that bogie is going away from you. What happens when an arrow comes towards you? Well, you get scared. Apart from that, it looks like a dot. So anything which is coming towards you is a dot. Anything which is going away from you is a cross. That's why the z-axis is a dot, because x cross y, I cross j is a k which is coming towards you. Understood? This is the sign convention they follow. Perfect. Good. Calculate the area of the parallelogram. Now I have I plus 2j plus 3k, 2i minus 3j plus k. What do I do, guys? Well, so they've actually, okay, fine. Hold on. So the area of the parallelogram is a cross b. First I need to solve for a cross b. How about let me take this opportunity to draw the determinant again for you. First row, I, j, k. Second row, the first vector, 1, 2, 3. The third row, the second vector, 2, minus 3 and 1. The first term, I. 2 minus 2 minus 9, 2 plus 9. Then comes j. J is the middle guy, opens with a minus sign. J, 1 minus 6 plus k minus 3 minus 3 minus 4. So I have 11i cap plus 5j cap minus 7k cap. Did you see that? How it becomes super easy using determinant. Once I have that, find the magnitude of that vector and that gives you the area under root a square plus b square plus c square if those are the components, and you get root 195. Applications of cross product. You can find the area of the triangle. Well, area of the triangle is nothing but half the area of the parallelogram. That means area of the triangle will be simply half of a cross b, half of ab sine theta, half of base into height, which is the area of the triangle, because the diagonal will divide the parallelogram into 2 parts. Got it? Perfect. Calculate the area of the triangle. What should I do now? I, j, k, good. If the third term is missing, put 0 there. And the k term will be 0. I, let's open this. I, 0 minus 0. There you go. Minus j, 0 minus 0 again. Plus k, 3 into 7, 21. 21 minus of minus 12, 21 plus 12, 33k cap. Can I check whether it's correct or not? Yes. Both the vectors contain only I and j. That means both the vectors are in which plane?